We're going to factor some special patterns today. So we did these back in Algebra 2. The first one we're going to look at is factoring a difference of squares. So if you have two perfect squares that are being subtracted, you can factor it into the first thing that's being squared minus the second thing that's being squared times the first thing that's being squared plus the second thing that's being squared, or square roots if you want to think about it that way. So let's run through one here real quick. So if you look at these, the 25x squared and 64 are perfect squares because you can get 25x squared by squaring 5x, and you can get 64 by squaring 8. You can also think about square roots if that's easier for you to think about. If you do the square root of 64, you get 8, so it's a perfect square. And if you do the square root of 25x squared, you get 5x, so that's also a perfect square. And they have to be subtracted, not added, because that's the only way that having one positive and one negative will give you 0 in the middle. So I can factor this into 5x plus my 8 times 5x minus my 8. And you can double check it by multiplying it back together. We're going to do one that is a sum or difference of cubes instead of squares. So if you look at x cubed and 8, those are not perfect squares. Those are perfect cubes. So if you think about what's being cubed, to get 8, I'm taking 2 to the third power, or you could think cube root of 8. And then, well, I'm cubing x to get x cubed. So I'm going to rewrite this as those two values raised to the third power, and then use my pattern for difference of cubes. So I kind of just block this out here first, and then fill things in. So your first set of parentheses is your terms that are being cubed. So you'll have x and 2 in there. So basically drop off your cubes. And then in your trinomial, you're going to have your first term squared, so that'll be x squared. And then I usually jump to the last term, 2 squared, right there. And then for the middle, you're going to be multiplying x and 2 together. So 2 times x. So it's basically drop off your cubes, square your first thing, square your second thing, first and last, and then multiply them together in the middle. And then for your signs, I use SOAP, kind of an acronym. It stands for like same sign as you had to start with, opposite sign, and then the last one's always plus or always positive, however you want to remember it. So I fill in my signs last. So same sign as what I started with. It was subtraction to start with. The opposite sign of that would be addition, and my last one is always a plus. And then if you can simplify, you should. So I'll square my 2 and turn that into 4, and then it'll be all factored and good to go. Note, this trinomial is never going to factor further, so you should be done. We're going to look at a difference of cubes that's a little bit strange looking. So if you look at this one, you have b plus 3, that quantity, cubed, minus 27, which is 3 cubed. So really this is a difference of 2 cubes. It's just one of your cubes is a binomial instead of a single variable. So it's still going to follow that same pattern. So if I write this, I'm going to have, probably should leave myself more space here, 2 terms and then my 3 terms. So my first thing that is being cubed is b plus 3. My second thing that is being cubed is 3. So I'll have b plus 3 and 3. And then I'll have my b plus 3 squared and my 3 squared. My middle term is those two values being multiplied together. So I'll have 3 times my quantity of b plus 3. And then I'm going to fill in my signs. So I should have Since it's subtraction, same sign that I started with, so subtraction. Opposite sign, so plus. And then the last one is always addition. Now this can have some simplifying done to it, because like b plus 3 minus 3, definitely want to subtract those and just get b. And then if you go ahead and square your b plus 3, take it times itself, you're going to have b squared plus 6b, because 3b and 3b, plus 9. And then this, if you take 3 times both of those, it'll give you a 3b plus 9. And then 3 squared is 9. So there's a lot of like terms that need combined in there. So I'll have b squared, let's see, 6b and 3b is 9b. And then 9 plus 9 will give me 27. So my final simplified result just looks like that, actually.